Welcome back to the Deep Dive. It is Wednesday, February 25th, 2026. And if you're plugged into the tech world at all right now, you know that all eyes are basically turned towards Spain.
Yeah, Barcelona, Mobile World Congress, it's the big show.
Exactly. MWC is in full swing. And usually, historically, when we sit down to talk about MWC, we're getting ready to dissect the latest smartphone screen refresh rates or...
Right, or maybe some new AR glasses that look slightly less like ski goggles than the year before.
Yeah, exactly. But today is different.
It feels completely different this year.
We are pivoting. We aren't talking about phones. We aren't talking about social media apps. We're talking about something that is arguably much bigger and, frankly, a little more intense. We're talking about physical AI.
Yeah, that's the phrase of the week. It's a massive shift in the narrative. Because for the last few years, really since the AI boom of the early 20s, we've been entirely obsessed with digital intelligence.
Chatbots, image generators.
Right, stuff that lives on a server and stays behind a screen.
It writes your emails, but it doesn't do your dishes.
Exactly. But the conversation in Barcelona has moved to operational AI, intelligence that actually inhabits a body and moves through the real world.
And at the center of this storm, at least for the stack of research we're diving into today, is a company called General Robotics. Now, here's the hook for everyone listening. They aren't just another hardware startup.
Right.
They aren't making a robot dog that does backflips on TikTok. They claim to be building the nervous system or the intelligence layer for all robots.
That is the claim. And to really understand if they can pull that off, we're pulling from a pretty diverse stack of sources today. We've got their technical white papers on agentic architectures and their GRID platform.
Which is pretty heavy reading, but we will break it down.
We will. And to give it some real-world context, we're pairing that technical stuff with a fresh dispatch from the ground in Barcelona. It's a LinkedIn article by Shish S. regarding the convergence of telecom and robotics.
Which sounds like a weird mix at first. Telcos and robots.
It does. It sounds like a really boring utility meeting.
Yeah, but by the end of this deep dive, I promise we're going to explain why your future phone carrier, the people you currently pay for 5G, might also be the ones managing the robot that delivers your groceries.
It sounds like sci-fi, but the infrastructure is literally being laid right now.
So let's unpack this. We have to start with the technology itself, because General Robotics has a very specific philosophy that goes against the grain of what we've seen in AI lately. I feel like for the last few years, the hype has just been bigger is better. Giant models. The monolith.
A God model approach.
Right. One brain to rule them all. But General Robotics is saying, no, that's actually a terrible way to build a robot.
It is a key distinction in their research. And to understand why, you really have to look at the difference between a chatbot and a robot. If you use a massive large language model, a monolith, it works great for text. It predicts the next word. But it's a black box.
Meaning we don't really know how it got to the answer.
Exactly. And it's slow. And sometimes it hallucinates. Now, if a chatbot hallucinates, you get a weird sentence. If a 200-pound robot hallucinates in a warehouse...
You get a hole in the wall. Or someone gets hurt.
Precisely. A monolith is just too slow, too power-hungry, and way too unpredictable for the physical world. So General Robotics is betting on modular skills.
I love the analogy that came up in the notes for this. It reminded me of Lego blocks.
That is the perfect way to visualize it. Instead of one giant, mushy brain trying to do everything at once, they break intelligence down into hard, distinct blocks. You have a perception block that just looks at the world. You have a planning block. You have an action block.
So they're literally separate pieces of software.
They are separate, specialized skills. And the magic, what they call agentic architecture, is how those blocks are put together.
And this is where the code synthesis part comes in, right? Because this blew my mind.
It's fascinating. The agent isn't just guessing what to do. It uses code synthesis to actually write a small program on the fly.
Wow.
It looks at the Lego blocks available and says, okay, to solve this problem, I need to connect block A to block B to block C. It composes the solution.
So it's not a static program. It's dynamic.
Completely dynamic. It weaves these skills together to solve the very specific problem in front of it in that moment.
Now, here's where it gets really interesting for me. The sources emphasize that this software is hardware agnostic. They use the word morphology.
Which is just a fancy biologist word for body shape.
Right. But think about what that means. A robot with wheels moves totally differently than a robot with legs, or a drone with propellers. How can the same intelligence layer work for all of them?
That is the power of that modularity we just talked about. The high-level planner, the part of the brain that decides what to do, doesn't need to know about the wheels.
It just knows go to the kitchen.
Exactly. It says go to the kitchen. It passes that command down to the locomotion skill. If that skill is installed on a dog robot, the legs start walking. If it's on a drone, the props spin up. The intelligence layer is abstracted completely away from the physical body.
That is huge. It's like the Android moment for robotics. You don't need to rewrite the entire operating system just because you change the hardware.
Precisely. And they list some specific research advancements in their history that make this possible. Did you catch the mention of Mamba?
I did. It sounds like a dance move,
Yeah.
but the text says it's an elastic neural network architecture. Why does it actually matter to you, the listener?
Efficiency. That's the key word. Most big AI models today are incredibly heavy. They require massive server farms of GPUs, but robots run on batteries.
Yeah, that's true.
You can't have a supercomputer draining your power source in 10 minutes just thinking about how to open a door.
So Mamba is lighter.
It's incredibly efficient. It's based on state-space models, which are linear. It allows for high-level intelligence without burning through the battery. It's what makes this practical for a machine that isn't plugged into a wall.
And they also mentioned dream control specifically for humanoids.
Yeah, that's their specialized skill set for bipedal movement. Walking on two legs is really, really hard.
I mean, it takes toddlers long enough.
Exactly. Dream control allows the AI to learn that balance in simulation, they call it dreaming, before it ever tries it in reality.
Oh, and the sources also brought up Video Poet and AirSim in that context, right?
Yes. Video Poet is a video generation model, and AirSim is a high-fidelity simulator. They use tools like these to create endless synthetic training environments. The robot can practice flying or moving through thousands of generated scenarios without ever leaving the server.
Which actually segues perfectly into the product itself. Because General Robotics isn't just writing academic papers. They're actually selling a platform called GRID.
The General Robot Intelligence Development Platform.
It sounds like something straight out of a cyberpunk novel. The GRID. But they have two flavors of this, right?
They do. They have OpenGRID, which is entirely web-based. That's for the hobbyists, the students, the prototypers. You can go in, mess around with skills, see how it works.
But then there's the heavy hitter, GRID Enterprise.
That is for the big players, large organizations, massive logistics fleets.
The stat that absolutely stopped me in my tracks was the speed. They claim you can go from prototype to deployment in under 15 minutes.
It's an aggressively fast claim.
How is that even physically possible? I mean, usually calibrating a robot takes days of engineers in hard hats tweaking sensors on a warehouse floor.
It comes back to that sim-to-real workflow we touched on with Dream Control and AirSim. They're leaning heavily on high-fidelity simulations, using tools like NVIDIA Isaac Sim alongside their own tech.
So the robot practices in the matrix first.
That's the best analogy. If you want to teach a robot to pick up a glass of water, you don't want it to drop 1,000 actual glasses in your kitchen. That's messy and super expensive.
And dangerous.
Right. So you let it drop 1,000,000 virtual glasses in the cloud. It runs through those scenarios at lightning speed using synthetic data. Once it creates a stable policy, a skill that works, you just download that skill to the physical robot.
So the 15 minutes isn't training time. It's downloading the muscle memory time.
Exactly. You are deploying a skill that has already been perfected in the simulation.
And we aren't talking about one robot here. The scale mentioned in the source material is wild. 25,000 plus concurrent robot requests per instance.
That number is the real giveaway. 25,000 requests isn't for a guy with a drone in his backyard. That is a system for a fleet. That is for an Amazon fulfillment center or a city managing a massive swarm of inspection drones.
Which brings us perfectly to the scene in Barcelona right now. Because if you have 25,000 robots needing instructions, you need a network that can handle it without crashing.
And that is exactly why General Robotics is at Mobile World Congress.
Let's look at this LinkedIn article by Shishes. The title is General Robotics at MWC 2026, Orchestrating the Intelligence Layer for Physical AI in Telecom.
It frames the situation perfectly. The article notes that General Robotics has joined the Microsoft for Startups delegation, but the core argument is about an inflection point.
Inflection point. I see that phrase a lot in tech, but what does it actually mean in this context?
It means we're seeing a massive convergence. On one side, you have telcos, the people who run the internet and phone networks. They are terrified of becoming dumb pipes.
Just the utility company that lays the cable while everyone else makes the actual money.
Right. They need a new revenue stream. And on the other side, you have these robots leaving the factories and entering the real world. Retail, streets, hospitals.
And they need each other.
They desperately need each other. Shishes outlines 3 strategic drivers for why telcos love this platform.
Okay, let's go through them. Driver number 1.
Edge intelligence.
Explain the edge for us.
Okay, simple physics. If a robot is crossing a street and sees a car coming, it needs to stop immediately. If it has to send that video data all the way to a centralized cloud server in Virginia, wait for the server to process it, and send the stop command back.
The robot is already roadkill.
Exactly.
Yeah.
That delay is latency. To be safe, robots need incredibly low latency. Telcos own the edge. That's the computing power that sits really close to the user, like at the base of a cell tower or in a local exchange. By running the GRID platform at the edge, decisions happen instantly.
So the telco isn't just moving the data, they are literally hosting the brain.
Correct, which leads to the second driver, managed services.
This sounds like the big business model shift.
It is. Think about it. Telcos already manage networks. They manage millions of phones. The logical evolution is that they will manage robotic fleets.
So instead of just selling me a SIM card for my delivery bot, they sell me the whole package.
Exactly. It's bundling. Connectivity plus compute plus robotic intelligence. Imagine a smart city contract. A telco could go to a mayor and say, we will provide the 6G private network, the edge servers, and the orchestration layer for all your trash-collecting robots and traffic drones.
That is a massive shift from we provide the internet to we run the city's physical operations.
It turns physical reality into a managed service.
And the third driver mentioned.
Governance.
This one feels less technical and more legal.
It is, but it's crucial. Telcos are heavily regulated. They're trusted entities. They have to comply with laws. They can't just run wild experimental code on their networks.
Which loops us right back to the general robotics philosophy, beyond the black box.
You see how it all connects? The source material explicitly discusses blame assignment.
I saw that phrase. It sounds a bit harsh, doesn't it? Blame assignment. Like a manager walking around pointing fingers.
In engineering and insurance, it's a very good thing. It's the holy grail. It means if a robot drops a box or bumps into a wall, the system can tell you exactly why.
Because it's modular.
Exactly. You can look at the logs and say, okay, the vision module saw the wall, but the trajectory module calculated the curve wrong. You can pinpoint the exact point of failure.
Contrast that with the monolith black box model.
With a monolith, if it fails, the answer is just, well, the AI hallucinated, or the weights aligned poorly.
Which is not an acceptable answer in a court of law.
And certainly not acceptable to a telco that is legally liable for the service. General Robotics builds these mechanisms into the architecture. Safety isn't a layer they add later, it is the foundation. That inspectability is why telcos who care deeply about liability and reliability are so interested in this specific platform.
So they're solving the safety problem by making the brain modular so they can check which part of the brain actually messed up.
Precisely. And there's one more layer to this governance piece that the sources mention. The hardware-agnostic part prevents lock-in.
Oh, that's huge. Companies hate being locked into one vendor.
Right. Think about how it works now. If you buy a fleet of robots from Company A, you usually have to use Company A's software. If you buy drones from Company B, you use their app. It's all siloed.
A logistical nightmare if you're trying to run a warehouse with both.
Exactly. But GRID lets you orchestrate a warehouse robot from brand X, a drone from brand Y, and a security bot from brand Z, all on one single dashboard.
It's the Android of robotics. It commoditizes the hardware.
In a way, yes. It becomes the orchestration layer that sits above the hardware. It gives the telco or the enterprise complete control over a mixed fleet without being chained to one hardware manufacturer.
So let's recap the picture here. We have the tech, which is modular, safe, fast. We have the partner, telcos who have the edge infrastructure and the desperate need for new revenue. And we have the use case, managing fleets of diverse robots in the real world.
It really paints a picture of 2026, not as the year of the chatbot, but the year the internet gets hands.
That is a great line. The internet getting hands.
And if you look at the world models concept mentioned in the list of articles by Sheesh S., it suggests we're moving past just language. We're entering an era where AI actually understands physics, causality, and time.
So what does this all mean for you, the listener? Why should you care about what's happening at a telecom booth in Barcelona today?
I think what here is about visibility. For the last decade, robots have been mostly hidden away. behind factory gates, inside massive fulfillment centers.
Out of sight, out of mind.
Right. But with platforms like GRID and the backing of global telco infrastructure, the cost and complexity of deploying robots drops dramatically. You don't need a PhD in robotics to run a fleet anymore. You just need a subscription to the platform.
So we are going to see them everywhere.
They are becoming standard traffic. Just like video data or voice data, physical action data is becoming just another packet on the network.
That is mind-bending. We're moving from a world of isolated robots to a world of orchestrated intelligence.
And it's likely powered by the exact same network that you use to scroll social media.
It really makes you think about the future of our daily environment.
It does.
You know, I want to leave everyone with a thought here. We talked about telcos managing this. We talked about managed services. If AI is moving from answering questions to navigating the physical world, and if telcos are the ones managing that navigation,
I think I know where you're going with this.
are we looking at a future where physical reality effectively becomes just another managed service you subscribe to? Like, sorry, I can't mow the lawn, my physical reality subscription is down. Or, I can't get my groceries delivered, I hit my data cap on physical interactions.
That is a very provocative thought. If the intelligence of the physical world is centralized and managed by service providers, that changes our relationship with our environment completely. We become dependent on the network, not just for information, but for physical action.
Something to chew on while you wait for your next grocery delivery, which might just be orchestrated by your phone carrier.
Indeed.
Thanks for diving in with us. We'll catch you on the next one.